So, have you ever thought about building a project that uses a display, but you thought, oh, I have too small of a microcontroller, such as this one right here, and you don't have enough I/O pins to give up? Well, in this example here, I'm controlling that display there with just two I/O ports right here. Because two of these lines here are powered, like 5 volts and ground, and the other two are going to be going straight into the I/O pins. There's nothing in the way, by the way, straight in. And it doesn't matter which two I/O pins, and it doesn't matter which microcontroller from Microchip, because what I did is I developed a, it only took me a few days, but I developed a serial port communication routine so I could just simply communicate regardless of whether I had the drivers. So you don't need the, I think they use I2C communication with these boards. And that's basically what I built, was an I2C communication subroutine. Anyhow, these are the boards right here on the top that make it possible to run only a few lines into your boards. If you didn't have these boards, it'd be like 10 I/O ports or something taken up here. Quite a few to make this display work. But other than that, this is used for dimming or contrast or something with the display. But the little yellow line here I used to light up the back display. It's the only way I could figure out the back light. And there's the same thing running between this point here and this point right here on this board. It's just the wire is hidden. You don't see it. But they're about $13 a piece. And Amazon was where I bought mine. I bought maybe 3 for about 39 bucks for that one. This is, by the way, unrelated to the project, okay? Now, let me show you, I'll show you the coding. Might be something that you might find useful. Let me just run over to the coding here. It starts up here somewhere. And, I'm sorry, I'm using a 12F1612. It really doesn't matter which chip you use from Microchip. You just have to subtly change the software based on your chip, and obviously which I/O ports you're going to use. And I'll show you what this code looks like, so you can decide if it's something that you can implement. It's all open source, not a big deal. So yeah, I'm just skimming quickly so you can spot it. So that's the end of the program down at line 116, because the rest of it is just the data that's going to be landing on the display. So every one of these lines represents one character for the display. And so obviously it's a 80 character display. It's going to use 80 bytes of data to get that to land on the display. So let's just go back over here. I want to show you some more stuff here. Those characters, you're probably thinking, how would I know which characters? Well, this is the data sheet from the display manufacturer, and I guess it's from China. And right down here tells you which characters or which numbers are associated with which characters. So this is the explanation right here. So you can figure out which one of these characters you want to show, or which characters and how to stick them together and make the words that you want. Something like that, right? So I'm going to just turn the display on. What I got to do is I have to go over to my camera and dim the lights down, because honestly, this actually is a really nice display, but it does not look very good when there is bright light. So the light is off and the display is on. And it's very quick. So that came on pretty quick. Can I move the camera closer? Probably. Boop. So yeah, you can see going from off to powering up, it's like a half a second. It just throws all the characters on really quickly. If you have any questions, leave a comment. Thanks a lot for watching.